We are going to solve one-step equations with addition and subtraction. An equation just means that one side is equal to the other. You can almost hear the word equal in equation. The root word, the beginning of equation, starts with equal. Anyways, you have to keep both sides equal in an equation. That's the object of an equation. We're trying to figure out, as we're keeping both sides equal, what the variable equals. Now, a variable is a letter that represents a number. Since we don't know what the variable stands for, that's what we're trying to figure out. What does X stand for? What does X mean? What number fits here for X? Okay, so we have X minus 3 equals a negative 4. An equation is a lot like a seesaw. A seesaw, usually when you get on one, you want to go up, you want to go down. You want to have somebody who weighs something different from you so that you guys can both push yourselves up. But have you ever gotten on a seesaw and both of you were like the exact same size, and that seesaw did not go up and it did not go down? It stayed right there in the same place. It was very boring. Well, that's kind of what you want to do with an equation. You want it to stay equal. You want to stay even. You don't want it to go up. You don't want it to go down. You don't want one side to be higher than the other or not the same size as the other. You want the same number on both sides. So we want to keep an equation equal. To do that, if I'm sitting on a seesaw and the other person across from me is the exact same size that I am, well, then say that we add a 10-pound weight to my side. And that other person's going to end up going up in the air, because we're unequal now. So to get us equal again, we would have to add a 10-pound weight to the other side to keep us equal. So whatever you do to one side of the seesaw, you have to do it to the other side to keep the seesaw equal. So let's look here. X minus 3 equals negative 4. X minus 3 is like the left side of the seesaw, and the negative 4 is the right side of the seesaw. Right now, the seesaw is equal. So let's figure out what X is, and let's keep both sides equivalent. Because to figure out what X equals, we need to keep them the same or equivalent. So X minus 3, this is a minus 3 or a negative 3 because the 3 has a negative sign in front of it. So I'm going to add 3. That's the opposite of subtracting 3. We're using inverse operations, the inverse property. So negative 3 plus 3 is just 0. I added 3 to this side of the seesaw. I have to add 3 to this side, plus 3. This is going to give me a negative 1. So now I have X all alone on the left side and negative 1 all alone on the right side. Let's look at that down here with our seesaw. Now this is a fulcrum, the center of a seesaw. This is the right and this is the left. This algebra tile stands for X, and these 3 red negative tiles stand for negative 3. On this side of the equation, or of the equal sign, we have negative 4 negative chips. All right, what's the first thing we did? We did the inverse operation of subtracting 3. We added 3. We're using the additive inverse property here. We're adding 3 to this side. When we do that, I'm going to put 3 positive integer chips. We'll practice this in class. And whatever I do over here to keep it equal with this side, I have to add 3 over here. All right. When I add 3 to this side and this side, what happens is a negative and a positive get together and they cancel out. So I'm just left with X. And on this side, this positive and this negative are going to cancel each other out. Oops. And so I'm just left with negative 1. Over here on this side, I have negative 5 equals n plus 2. So I need to get n by itself by using inverse operations. I'm going to subtract 2 from both sides. It's going to cancel out over here. And I'm going to end up with a -7 because remember, a negative plus a negative or a negative and a negative together are going to give you a negative, even more negativity. So n equals -7. Let's look at it down here with our integer chips. So I have -5, 5 negative chips on the left side, and on the right side I have n, which is my green algebra tile, and 2 positive chips. Now, I'm going to use inverse operations. So I started over here on the side with the variable because the object is to get the variable alone. And I'm going to subtract 2. -1, -2. And I'm going to do the same to the other side. Subtract 1, subtract 2. Now when I do that, over here on this side, these are going to cancel out because a positive and a negative together just cancel. I'm left with n all by itself, or my variable alone. And on this side, I have 1, 2, 3, 4, 5, 6, 7 negative chips. Let's look at the addition property of equality. The addition property of equality says that if both sides of the equal sign are equal, then if I add something on the left, I have to add it on the right. So in other words, this is the left side of my seesaw and this is the right side. If I add 5 pounds to the left side, I have to add 5 pounds to the right side to keep it equal. This is going to give me P equals 3. If I have x minus 5, 6, if I add 5, 6 to this side, I have to do the same on this side, which is going to give me x equals 4/6, or 2/3, when I simplify. The subtraction property of equality says the same thing as the addition property of equality, except this time we're taking some weight away from each side of the seesaw. So look here, we have w plus 13 plus 2, 13 and 2/10 equals 10 and 4/10. So if I subtract 13 and 2/10 from this side to cancel this out to get w alone, I have to subtract it from the right side also. So I'm left with w equals, and remember, when you have a positive and a negative, you're going to subtract the two number values and you're going to take the sign of the greater absolute value. So -13 has a greater absolute value, is further from 0, so I know it's a negative. And then 13.2 minus 10.4 it's going to give me 2 and 8/10. So a -2 and 8/10. The second one, same thing. I'm going to subtract from both sides, minus 2/3 minus 2/3. I get r equals 1/5 minus 2/3. I'm going to have to do a little work to solve this one. So I'm going to do it down here in the corner. I need a common denominator. So 15 is a good one. I get 3/15 minus times 5 times 5, 10/15. And I have a positive and I have a negative. So there's more negativity. I know my answer is a negative. And when I put 3 and -10 together, I owe $10. I have $3. It's a -7. I still owe 7. -7/15 is my answer. R equals -7/15. If I plug -7/15 in for R, I will see that if I add that to 2/3, I'm going to end up getting 1/5. And I can plug in all of these other values for W, the 3 for P, 3 minus 5 is -2, and the 2/3 for X, or the 4/6, and I'll see that I'm going to get a -1/6. Okay, here's the pause it section. Go ahead and pause the video. Try these out using the addition property of equality and the subtraction property of equality to solve these. Remember, whatever you do on the left side of your seesaw, you have to do on the right side of your seesaw to keep it equivalent, and that the object is, you're trying to figure out the value of the of your variable. All right, m plus 6 equals -4. Subtract 6. Use inverse operations to get the m alone, the variable alone. So we're going to subtract 6. We're going to subtract 6 from the right side of the equal sign. When we do that, we get -10. So m equals -10. And when I plug -10 in, I get -10 plus 6 is a -4, and that's correct. All right, the next one, we have -4 5/10 equals d minus 2 1/10. So I got to get the variable alone. So I want to get rid of the -2 1/10 or the -2 1/10. Use inverse operations. Since I'm adding 2 1/10 to this side, that cancels out. It becomes 0. And then I'm going to add 2 1/10 to this side. I'm adding a negative and a positive. The signs are different, so I'm looking for the difference between the numbers, and my answer is going to take the sign of the greater absolute value, which is negative. Okay, so 5 minus 1 is 4. 4 minus 2 is 2. And the distance between them is 2 4/10, and it's a -2 4/10. If I take -2 4/10 and subtract 2 1/10, that's negative and a negative, so I add two number values, which is 4.5, -4.5. Let's go to this one. Q plus 1/4 equals 4/5. So I am going to subtract a fourth using inverse operations. So this is subtraction to turn this into 0. And I'm going to subtract 1/4 here. All right, when I do that, I need to get common denominators. 16/20 minus 5/20, because 20 is a good common denominator, least common multiple between 5 and 4. 16 minus 5 equals 11/20. So if I plug 11/20 in, I have 11/20 plus 5/20, which would be 16/20, which reduces to 4/5. So that would be correct. Let's go to the last one. F minus 1 1/3 equals 2 3/4. So we get we add 1 1/3 to this side to cancel out the -1 1/3. We want to get f alone, and so we use inverse operations, the opposite of what is here. This is subtraction, so we use addition. All right, additive inverse property. Now I'm going to go over here and do the same thing to the right side of my seesaw. So I'm adding 1 1/3. I've got to get like denominators. 12 is a good like denominator. So get 2 9/12 is my new fraction, or mixed number, and 1 4/12. Okay, and now I'm going to add those two together. So 2 plus 1 is 3, and 9 plus 4 is going to be 13. I can see here that there's another whole, because 12/12 is a whole, so that's 4 and a 12th. So F equals 4 1/12.